Okay, Walkers. So we're going to on page 59, modeling exponential growth and decay. Exponential growth function. The exponential growth function is y equals a parentheses 1 plus r to the t, where a is greater than 0. The exponential growth function is represented by the graph here. Exponential decay function. The exponential decay function is y equals a parentheses 1 minus r to the t, where a is greater than 0. The exponential decay function is represented by the graph below. All right, let's take a look at the first example. All right, graph the function, then enter the domain of range and end behavior and an asymptote. All right, so let's first graph this. Okay, so to do that, we're going to use our calculator. So we're going to go to on, new document, no, add graph. We're going to graph 200, parentheses 1.15 to the x. Now, first things first, we're going to go to menu, view, grid, line grid. All right, now we're going to go to menu, window zoom, window settings. Now, when you adjust the x min is 0, the x max is 10, our scale is 1, the y min is 0, the y max is 1000, and our scale is 100. Press OK, and you can see that the graph is answer choice A. Okay. The domain is from negative infinity to positive infinity. The range is y greater than 0. The end behavior is as x approaches negative infinity. It's a little hard to see. Negative infinity. Y approaches 0. And as x approaches positive infinity, y approaches positive infinity. And there's an asymptote at y equals 0. And we're going to go ahead and do our asymptote, which is a dashed line, and we're going to add that to our graph. Okay? So our asymptote is at y equals 0. All right. Let's take a look at the next example. All right. So we're going to graph this. Okay. So we're going to go to our calculator. You always want to go to new document, no, add graph. And if you want, let's go ahead and view, grid, line grid. Let's go ahead and start with the line grid. And then we're going to type in 500, parentheses, 0.81 to the x. Now we need to adjust the window. So we're going to go to menu, window zoom, window settings. And the x min is 0, x max is 10, scale is 1, y min is 0, y max is 1000, and the scale is by 100. Okay. And then we can look at our graphs, and we see that the answer choice is D. Okay. Our domain is x from negative infinity to positive infinity. Our range is y such that y is greater than 0. Our end behavior as x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y approaches 0. Okay, now our asymptote is at y equals 0. And let's go ahead and add that to our graph. Okay, let's go and take a look at the next example. All right, enter the exponential function using t for time as the independent variable to model the situation. Then find the value of the function after a given amount of time. Annual sales for a company are 150,000 and increase at a rate of 7% per year for 9 years. So the exponential function models the situation. Y equals the initial value, so 150,000, times 1 plus 7% is 0.07 to the t. Now, to find this, we're going to plug in t equals 9. Okay? So we're going to go ahead and do that. So we're going to go to on, new document, no, add calculator. So we're going to do 150,000 parentheses 1 plus 0.07 to the 9, and that's our value. All right, so I want to put the t equals on here and then the value right there. So after 9 years, the company's annual sales are $275,000. All right, let's go and take a look at the next example. All right, enter the exponential function using t for time as an independent variable to model the situation. Then find the value of the function after a given amount of time. The value of textbook is $62 and decreases at a rate of 13% per year for 15 years. So the equation is the initial value, 62, times 1 minus 0.13 to the t. And then here, we're going to put t equals 15 into the equation. Okay, so delete the previous problem. So 62 parentheses 1 minus 0.13 to the 15, and our value is, now they want it to the, we're talking about money, so that's 7.68. Okay, go ahead and finish up that example. All right, example 10. Enter the exponential growth function using t for time as an independent variable to model the situation. Select the graph of the function, enter the function domain and range, then complete the explanation of what the y-intercept represents in the context of the problem. If necessary, round to the nearest cent. The value of the collectible baseball card is increasing at a rate of 0.5% per year. In 2000, the card was worth $1,340. Find the value of the card in 2013. So the equation is 1340 times 1 plus 0.005 to the t. Now, to find out what t equals, we need to come over here. So we know 0 is 2000 and 1 is 2001. So 2 is 2002, 3 is 2003, 4 is 2004. So dot, 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 dot. If you can kind of understand the pattern, then 13 equals 2013. Okay, so t equals 13. All right, so let's go ahead and plug the value in. So 1340 parentheses 1 plus 0.005 to the 13, and then that's 1429.76. Okay, now to select the graph, we're going to come back and graph this. So we're going to go to On, New Document, No, Add Graph. So that's 1340 parentheses 1 plus 0.005 to the X. Let's go ahead and do Menu, View, Grid, Line Grid. And then we need to adjust the window. Menu, Window Zoom, Window Settings. So the X min is 0. The max is 20. Scale is by 5. Y min is 0. Max is 2000. And the scale is by 500. Okay. So I'm going to do that. We see that our graph is answer choice D. Now, the domain is a set of all real numbers. T is greater than or equal to 0. And the range is a set of all real numbers. Y greater than or equal to 1,340. The y-intercept is 1,340. The value of y when t equals 0, which is the original value of the card in 2000. And all right, go ahead and finish up example 10. All right, let's take a look at example 12. Enter the exponential growth function using t for time as the independent variable to model the situation. Select the graph of the function, enter the function's domain and range, then complete the explanation of what the y-intercept represents in the context of the problem. If necessary, round to the nearest cent. The value of the movie poster is increasing at a rate of 2.5% per year. In 1990, the poster was worth $35. Find the value of the poster in 2013. Okay, so our function is 35.00 parentheses 1 plus 0.025 to the t. All right, now to find out what the t value is, we need to come over here. Now 0 equals 1990. 1 equals 1991. 2 equals 1992. 3 equals 1993. 4 equals 1994. 5 equals 1995. 6 equals 1996. 7 equals 1997. 8 equals 1998. 9 equals 1999. 10 equals 2000. So we want to get to 13. So dot, 23 equals 2013. Okay, so t equals 23. So now let's use that, and we'll go to the calculator. On, New Document, No, Add Calculator. So that's 35.00 parentheses 1 plus 0.025 to 23 is 61.76. Okay. Now to graph, let's come back to here and let's graph that. So we're going to go to on, new document, no, add graph. So 35, parentheses 1 plus 0.025 to the x, enter, and we're going to go to menu, view, grid, line grid, and then menu, window zoom, window settings, and the x min is 0, x max is 20, scale is by 2, y min is 0, y max is 50, and y scale is by 5. Press OK. And we can see that our graph is answer choice A. All right, let's take a look at example 3. Enter the function domain and range and complete the explanation on what the y-intercept represents in the context of the problem. So t is greater than or equal to 0. The range is y greater than or equal to 35. The y-intercept is 35. The value of y when t equals 0, which is the original value of the poster. All right, go ahead and finish up example 12. All right. Example 13. The value of a certain car can be modeled by the function y equals 15,000 times 0.72 to the t, where t is the time in years. Will the value of the function ever be 0? Well, let's take a look. So we're going to graph that. So we're going to go to on, new document, no, add graph. So that's 15,000, parentheses, 0.72 to the x value. Now, we can look at the graph, but honestly, let's go ahead and look at the table, okay? And we're going to see if it ever goes down to 0. And you can see we keep going, and it's close to 0, but it's never going to 0. Okay, so the table shows us it doesn't go to 0. So now we're going to go to Control T. And one of the things, if you can't adjust the window, we can always go to Menu, Window Zoom, Zoom Fit. Okay, and then what you see here is it gets closer and closer and closer, but it never touches 0. Okay. So the value of the function will never be 0 because the right side of the function is a product of positive numbers. Although the value can become extremely close to 0, it can never equal 0. All right? So go ahead and finish up your example, start working on your assignment, and have a wonderful Wildcat day.